Hello, everyone. Thank you for joining us today. I want to thank you for joining our presentation. My name is Catherine Hershey, and I am a member of the Illuminating Engineering Society and the Vice President for the IES Raleigh section. I'm also specification sales for Sesco Lighting. I'd like to welcome you to our presentation on product transparency for the future of healthy buildings. We have a great discussion lined up for you today. And today we're happy to welcome Aaron Smith, who is the VP of Technology and R&D at FineLight. He is also an alumni of the Lighting Research Center. He supports the development of energy efficient, high quality, and sustainable lighting. He also supports FineLight's new technology, integration, new product development, and research efforts. So thank you so much for joining us, Aaron, and I'll let you take it from here.
All right. Thanks, Catherine. And thanks, Lynn, for inviting me here to talk on this subject and also the Raleigh IES group. I'm excited to be here and hope to share some great information with you guys. So let's get started. I'm going to stop my camera and start the presentation here. All right. Like Catherine said, this is product transparency for the future of healthy buildings. I'm the Vice President of Technology and R&D at FineLight. This is an AIA accredited course, so don't hesitate to put your name in the chat if you need those CU credits. So what we're going to talk about today, we're going to understand what it means to design sustainably from a lighting perspective. We're going to cover things like social transparency, material transparency, and environmental transparency, and understand how that works through the building process. I've got a case study to look at. I'm going to explain the Declare program, as well as what LCAs and EPDs are and what that all means, and then how we can I like to say start small, think big, and get going, and how we can get going and apply these things to our building designs and or our product designs if you happen to be a manufacturer. So what is sustainable design? I like to think of three different things. One, we want to create practical solutions to the challenges posed by climate change. Things that we can really make actionable in our designs or our product development, and try to apply these best practices to minimize these negative effects from the environment or social economic impacts, while also improving the health and the comfort of the people in the space. And finally, the third thing is creating long-lasting solutions that help make the building self-sufficient and high-performing, or those products in the building that we're putting in there. And this has three main impacts: economic, social, and environmental. From an economic standpoint, we're looking at doing things like sustainable design can help us reduce operating costs or optimize building performance. In many cases, it's shown to enhance property values. From a social standpoint, we want to have positive impacts on the people and the communities with which we're designing these products and buildings in. Help increase employee productivity, and enhance employee well-being just generally. And finally, from the environmental standpoint, understanding the amount of energy that goes into making a product or a building, and trying to optimize that to help reduce the waste and the carbon impact that goes into that, and saving energy as well. But we can't overlook that this needs to be in harmony with the lighting design. And this is one of my favorite images. And when I first gave this presentation, a gentleman named Earl Levine mentioned to me, he said, "Hey, don't forget about the lighting design as part of the process." So we actually are always starting with making sure that we're meeting the needs of the people in the space from the lighting design perspective. And we have to remember that we're trying to design sustainable design are also application efficient designs and energy efficient designs. And there's a lot of effort that goes into the lighting design process to make it sustainable. And, we can't forget that as part of the process. So these things that I'm talking about today are what we're doing kind of on top of creating really sustainable lighting designs as well. And we can see just what kind of impact that has on both our visual performance and our human performance when it comes to a building. So we can't forget that one of the most sustainable things that we can do is design a really well-designed space from a lighting perspective. So just want to make sure that we understand that it's in harmony with that, what we're trying to do here. So who cares about sustainable design? Well, it turns out that all of the players within the built environment who are creating buildings or creating products for buildings are starting to be interested in the health and the sustainability of the product. So we're seeing that from architects to building owners to electrical engineers. They're starting to make it part of their process, and they're starting to ask for different transparency informations and real data to support that. And this is just an example of a situation where lighting designers asked the industry, hey, can you build more sustainable products? And manufacturers came back and said, yes, we can. And we'd love you to specify those in buildings. And this was kind of the reason for the LP50 and the lighting advocacy letter to really create this industry dialogue to create more sustainable products. So there is outside forces that are asking for these types of materials, and you can find these types of information in places like Mindful Materials. That's where the lighting advocacy letter is hosted, and learn more about that. But there's definitely a groundswell for asking for this types of information because people want to build more sustainably and understand what's really going into their products. And I want to give you an example of what this looks like in practice and why more and more people are thinking about designing more sustainable and how it's coming about. So one of the colleagues that I work with on some IES committees, Alexandra, she works for HMFH Architects, and she presented at Leducation, and she had a great set of slides about what they were doing in their company and what kind of goals that they were trying to achieve. So she's an architect, and the American Institute of Architects, they have their Healthy Buildings program. So that's one of their goals to try to accomplish the tasks around that. They're also looking at Architecture 2030, another challenge which they're trying to accomplish, and they're also trying to build sustainably using the Mindful Materials platform. So they have these three sets of kind of high-level goals that they're looking to achieve. And the IAA Material Pledge is challenging architects to think about these things throughout their design process, all the way from human health to the ecosystems to the circular economy, and build this into the whole design process. And this is an example of how this is playing out in Alexandra's design process. They're starting to engage the client in the pre-design phase. They're doing a set of goal setting, looking at different environmental factors from site design to daylighting to energy efficiency, how they can future-proof the building, create the sustainable design as a teaching tool, but also importantly, materials and reducing carbon. So today we're going to talk a lot about materials and reducing carbon and what this looks like from a practical standpoint. And you can see that this goes all through, ends up going through the full parts of the design phase. And how it is manifesting itself on a specification is they've created basically a tier system to basically kind of have a choice hierarchy. So at the top, you have tier 1. These are the types of products that are the most desirable. Then tier 2, tier 3, tier 4, if we can't find that, tier 5. And they've really kind of put this into their specification and communicated internally into the firm to understand this is how we're going to kind of make our decision, go through our decision-making process when it comes to looking for the types of accreditation for the types of products that we're going to put in the building. And you can see things on here like red list free documentation, product EPDs. And so throughout this presentation, I'm going to talk about what those are exactly, but I just want you to see kind of how this is being managed at a real architecture firm. And not only is it being managed in this way, but they're also doing the due diligence to collect the data to understand what the performance of the building is. So the data here isn't necessarily important, but it's to show really that the data is being collected for different parts of the building. So lighting would fall kind of under the MEP section, the mechanical, electrical, and plumbing section there, but they're collecting data for each of these things, and the only way that they can get this data is if they can get the data from the manufacturers and be able to kind of input it into their system so that they can understand it. So in this case, this is embodied carbon data. So the point of this is just to show not only are they setting these goals, but they're actually collecting the data so that they can say, how well are we doing with our design, and have some very quantitative way to show that. So really what I'm trying to show here is just exactly how sustainable design is influencing the specification. And then what we're going to talk about now is just what are those key things that we're seeing being done with lighting products today, and how is this being done from a lighting perspective on the product side. So there's really three main focus areas that people are asking data for. One is social transparency information. The other one is material transparency, and the third is environmental transparency. So I'm going to touch on all three of these. Social transparency is all about promoting diversity and inclusion and being a responsible business. Material transparency is about healthy materials and building healthy products, while environmental transparency is just about promoting the circular economy and reducing our carbon footprint. And I'll show you how this plays out practically for each of these different scenarios. So let's talk about social transparency first. So social transparency, the way businesses are showing what they're doing from a social aspect is they might be participating in one of several different programs. They might have a corporate social responsibility program where they've set goals for themselves and they are reporting it publicly on their website, and they're reporting it publicly to their shareholders. Both CSR programs and ESG programs are the types of programs that are kind of transparent and open. They involve goal setting and being shown how businesses are tracking to the goals that they set for these types of things. There are also third-party programs like the JUST program or Design for Freedom or B Corp that that businesses are participating in, that show just what they're doing from a social standpoint. And these are programs that have maybe have slightly different objectives, but these are the types of things to look for from a social transparency standpoint. And basically what these businesses are trying to show is like, hey, we're doing these things and we're holding ourselves accountable. And not only that, but we're also getting it third party verified by an accounting firm like maybe Deloitte and Touche or something like that to show that, hey, yes, they actually did what they said that they were going to do. So what do these goals kind of look like in practice? So they can range anything from gender diversity to the diversity of different supply chains, things like customer satisfaction, ethics, or just safe workplace. So really, companies might have different goals that they set for themselves, but the important thing here is that they're setting goals, they have a roadmap, and they're trying to kind of accomplish those goals. So some folks are even in the lighting space asking, hey, what are you doing from a social transparency standpoint? And this is the type of information that businesses are trying to provide and be able to show kind of what they're doing from a social transparency standpoint. All right, I wanted to touch on social transparency just so that you understood that, but we're going to go deeper dive into the actual product pieces. So this next section is about material transparency, and then we're going to go into environmental transparency. So It's really hard to understand what kind of chemicals are being used in a space if you're just looking at the space or you're just looking at a picture of the space. How do you know what any of this stuff is, or what things are made out of? And that's what material transparency is looking to solve. And one of the first steps was to create these lists of chemicals. And there's different lists out there, but one of the most popular ones and probably the most frequently cited is the red list. This is a list of over 800 chemicals. It was created by the International Living Futures Institute, who runs the DECLARE program. But essentially what they've done is they've identified kind of the most harmful chemicals. And what this allows us to do is to, if you know the chemical makeup of your product, you can compare it to this list and try to see if any of those chemicals are on that list. And then from a manufacturer standpoint or a building construction standpoint, you can say, hey, is there a way that I could kind of design out these most harmful materials, or try to use a different product that maybe doesn't have these types of materials? So it really helps highlight where you might have areas for improvement in a product design. So it's a really cool tool. And one of the things that this plays out, especially in lighting, is PVC is on this list, and PVC shows up all the time in electrical wiring components, but it happens to be kind of a harmful chemical. So what the creation of this list actually helps highlight for designers to say, hey, maybe we can think of different ways that we could create jackets for this wiring to make it not have PVC in it, or not to have this harmful chemical in it. And today we're seeing more and more options for wiring that doesn't have harmful chemicals in it. So it allows us to make a choice and design decisions that have a positive impact on the sustainability and health of products. So this is just one example that shows up in lighting quite a bit. So essentially what material transparency is simply just disclosing the ingredients that make a product. And there's several different programs out there, so I just want to name a few so you can kind of just get name recognition if you see it out there in the future. One is the DECLARE program. We're going to talk a lot more about that. There's also health product declarations, and there's also cradle to cradle. So very similar programs, just looking at helping you disclose the information in a really kind of organized way. So what kind of information are people providing whenever they're trying to get some of this information? So from a manufacturer standpoint or product standpoint, you need to collect the weight of the components. You need to know the ingredients down to 100 parts per million. You need to know the actual individual ingredients for each thing that might be in a component. So for example, let's say a plastic or an acrylic lens, it might be made up of 4 distinct different types of chemicals. Each one is going to have their kind of own serial number. That's a CAS number. And so you'll have 4 CAS numbers that make up a particular ingredient. It's basically just like a social security number for ingredients. You need to know the list of the suppliers. You need to know their formulations. So you might need to put NDAs in place so that you can get those formulations because it's proprietary. They don't want it disclosed. You would need to register for some of these programs, pay annual fees for getting the labels, do yearly renewals so that if your process changes, you can make sure that you update things, that things are current. And a lot of times you need to do kind of a more deep dive into it and make sure that nothing's changed over a longer period of time. So if you happen to be a manufacturer or a product designer out there, I do have some recommendations for how to go about being strategic about getting these labels, because there are some costs to them. The main piece of advice is to try to combine products and product families by material type or supply chain, so that you don't have to manage quite as many labels. Really start on the highest running products first to try to focus your attention and try to get that first label out and have the biggest bang for your buck there. And then try to track your sustainability sales and make it as easy as possible for specifiers to spec a product so that they know that it has a label. So make it part of your catalog number so that you know that, hey, I'm specifying a product that has a declare label. It's showing up on my lighting schedule. It shows up all through the process, and people know exactly what they're getting because it's kind of been made part of the process. So make it easy for folks. And then, apply these sustainability learnings to other products. Once you get one label, figure out how you can try to, one, make it part of your design process and keep that momentum going. So the reason why this is coming up more and more is because people are demanding transparency from their products. They want to know that the claims that people are making are in fact valid. So these labels help confirm those claims so that people can, make informed decisions. And in the past, we just had something like the red list, and every time there was a sustainable project, they'd say, "Hey, what kind of ingredients are in your products?" And they'd send us some paperwork, and people would have to fill out this paperwork. But now that there's these programs out there like Declare, they've created a system to help organize that data and make it easier to access. So I'm going to talk about one of those systems now, which is the Declare program that makes it a lot easier to access this type of information. So what is Declare? So basically, it's a free transparency platform and product database. So if you Google Declare database, you'll be taken to the International Living Institute's website. You'll see a database there. You can type in a company's name and see which products from that company have a Declare label. And basically, the Declare label is simply an ingredients list, just like your cereal box has ingredients for what goes into making food. This is ingredients for products. So what does the label try to help us with? It helps us with understanding where the product comes from, what it's made of, and what we can do at the end of life. So we'll go through a little bit about what's on these labels. So you can see where the product was made, what's the life expectancy, how long, what can we do with the products at the end of life, and then it really starts listing the ingredients there. And all of the ingredients that are kind of in black text, those are going to be things that are not on the red list. If there's an ingredient in the formulation that's on the red list, the text would appear in red. And if the ingredient is on the watch list, which is a chemical that the Institute is watching that may become a red list chemical, it would be highlighted in yellow. And what this does is give designers an opportunity to look back at their product designs and see, like, hey, can I further optimize my products here? So that's the ingredients list and how that works. And then at the bottom of the label, it shows essentially what kind of label it is. Is it a red list free label? Is it a red list approved? Or is it a Declare label? What percentage of materials were disclosed? When was the label issued? And when is it expire? And then was it third-party verified or not? So I mentioned that there's 3 different kind of labels, and it's important to understand the difference. In most green building systems, you can get points towards your credits for just having a Declare label, or you can get more points for having a different type of Declare label, either third-party verified or red list free. You might be able to get extra points for that. So let me explain the 3 labels. So the first step in material transparency is, the goal is to just get manufacturers to disclose the ingredients in their products, good or bad. And for doing that, you can get a Declare label. You get a Declare label even if you have red list chemicals in that product. You can get a Declare label. Now, red list approved is none of the ingredients that are in your product are on the red list, so they're essentially red list free. However, you've taken some kind of exception, and there's only one or two exceptions that you can take. And for lighting, it shows up quite a bit because it's a small electronics component exception. It's very hard to understand the chemical makeup down to 100 parts per million of all the different components that might happen to be in a driver or in an LED. It can be very, very, very difficult. So there's an exception for that. However, those components do need to be RoHS compliant. So in a lot of cases, you'll see lighting products that are on the declare list. The highest level that they can get is red list approved. So none of the chemicals that are in that fixture are on the red list, and there was some kind of exception taken, usually for small electronics there. So that's what red list approved is all about. And red list free is that every chemical in there is there's nothing on the red list, and there was no exceptions taken. So a lot of times you'll see this for products that don't have electronic components, like acoustic baffles from lighting, or lighting that might have a remote driver where they didn't use that as part of the submittal there. So that's where kind of red list free comes in. You'll see more products like chairs and cement and things like that that can get kind of the red list free because, they're not taking any exceptions. So that's the difference between the three different label types. Now, the last thing to understand is that is the third-party verification. So in order to get a declare label, you can self-declare it. You've accounted for all the materials, you've gone through the process of getting the label, and you've done that all yourself as either a manufacturer or a product designer. But an added layer of assurance is third-party verification. That's where you work with a third party who goes out, helps you get the information from the marketplace about your materials, sets up the NDAs, and verifies that all the information that they've collected or helped you collect is valid. So that's what third-party verification is. And in some cases, in some green building certificate programs, you can get extra points for products that have third-party verification. So how does this play out for a lot of the green building programs? You can get points that count towards your sustainability efforts for these programs by using products that have material transparency information. This shows up in LEED, Living Building Challenge, and WELL. So these are the types of things that are really helping push designers to kind of ask for this information, especially if they're participating in these types of programs. And at the end of the day, it just helps people make informed decisions about the products that they're not only installing in the space, but the products that they're building as well. All right. So we've talked about social transparency and material transparency, and now we're going to jump into environmental transparency. So environmental transparency is all about disclosing the environmental performance of a material, a product, or building system, looking at the complete life cycle and saying how much energy goes into all of these different steps that make up a product. And the things that people are creating from this are really two different things. The outcome of this is, one, a life cycle analysis, which is essentially a model of the environmental impact of a product from the extraction of the materials in the ground, the production of it, the transportation, the installation, all the way to the end of life. And once you have an LCA, you can take that data and summarize it down into something called an EPD, or an environmental product declaration. And this is where you basically summarize all the environmental impacts, and you make it so that ideally that you could take an EPD and compare it to another EPD because they're both looking at the same functional unit of a product. Now, there are different forms of this kind of summarization. One of them is an EPD. Another one is called a PEP. This is more of a European type program. And then there's some ones that try to simplify the process a little bit. CIBC TM65, some of the electronic data is harder to get, and so CIBC created something that tried to lower the bar to get more products getting kind of LCAs in. So the data might be a little bit more generalized, but you're trying to get more manufacturers to start that LCA process and start thinking more about how they're producing things. And then the third thing is industry sponsored EPDs. So this is where a group of folks get together, let's say 3 or 4 concrete manufacturers, they pool their data together, and then they leverage that data to create more of an industry-wide EPD for concrete that they make. So essentially kind of creating a baseline. Now in lighting, this is happening right now. There's a group called the Green Light Alliance, and several manufacturers have been involved throughout the industry to provide data to the Green Light Alliance about various different product types, from 2x2s to downlights, linear lighting, I believe bollards, and maybe post-top lighting as well, and maybe a street light. And basically trying to collect that data from several different sources and create an industry baseline for those different product types. So once they have an industry baseline, that would allow manufacturers and specifiers to compare against kind of more of an industry average. So this is one of the first attempts to creating an industry-sponsored EPD from a lighting standpoint. So that group is called, again, the Green Light Alliance, and I'm not sure if they published their data yet, but I think it should be out shortly. So what are the requirements for creating these environmental transparency things? What are the practical things that people are looking at or that you need to be able to provide? So you need to know the weight of the components, each individual component. You need to know what material types are used. You need to understand the manufacturing process. Was this an extruded aluminum? Was it steel? Was it progressively tooled? And you need to know the list of the suppliers, where the location of the suppliers are, what transportation methods you were using in order to transport those materials. Were you transporting them by boat, by truck, by plane? Was it on a pallet? What was the inbound transportation look like? What does outbound transportation look like? What kind of energy grid were those manufacturers on in the different locations? So if you're on the East Coast, it might be coal or nuclear energy, but if you're on the West Coast or northern, maybe it's hydroelectric or solar. So what kind of energy grid is used in the area where the manufacturing is happening, and what's the makeup there? Any NDAs that need to be put in place to kind of better understand those processes. And then there's certain costs that are associated here. So the reason why you don't see as many LCAs and EPDs in North America today is likely because of a cost barrier. So there's a lot of work going into how can we help reduce the cost of creating LCAs and EPDs so that we can get products, more and more people participating and getting product-specific EPDs. But there are costs, and then you also have to renew these things every so often so that you go back and look at your supply chain and see what's changed over a certain period of time. So these are kind of the basic steps that these are the basic components that make up a life cycle analysis. There are between 4 and 5 stages. I'm going to focus on these 4 because they show up in, these are kind of the main ones that show up in EPDs normally. This is a system that was developed in Europe, so it's a standardized type of system, a way of looking at the product life cycle. There's a product stage, which includes things like raw material extraction and product manufacturing. And there's also these, at the bottom, you'll see these numbers, A1 through A3. These are kind of the numerical numbers that are associated with it, and sometimes they show up on EPD documentation. So I just want you to be aware of it, this kind of A, B, C, and there's even a D nomenclature, just so you can orientate yourself. If you see an EPD in the future that has those kind of designations, you'll know what it means. So product stage, construction stage, this is like where the product is actually being installed on site or transported to a site. Then you have the use phase. This is where the product is actually installed and it's being used, and there's a certain amount of energy and electricity that's being used there to use it and maintain it. And then at the end of life, what happens when the product is done or it's demoed? What happens to that product at the end of life? And so there's a certain amount of energy there to take care of that. So all of that's accounted for in the life cycle analysis. So you can imagine the amount of kind of data that has to be looked at here. So once you've got that information, you turn it into an EPD. And so I'm going to show you an example of what an EPD or PEP looks like. This happens to be a PEP for basically a bathroom style light fixture. The first thing to note that I want to explain is just the functional unit. So for lighting, generally the functional unit is some level of lumens and certain lifetime. So the reason why there's a functional unit is so that different light fixtures with various different specifications can all be kind of compared together. So the best analogy that I can use for what a functional unit is probably something like concrete. So in concrete, you might say for every 1 kilogram of concrete, it is producing 100 kilograms of carbon. So that functional unit is that 1 kilogram. You could have 1 kilogram of wood produces 10 kilograms of carbon. And so it allows you to compare different material types together. And in this case, the functional unit allows you to compare different lighting types together. So if you saw two EPDs and one said, 1,000 lumens per 35,000 hours, and another one said 2,000 lumens per 50,000 hours, it would be very hard to compare those two things together. So if you want to compare different things, it helps to have the same functional unit. So that's the purpose of the functional unit. I know I went into great detail on that, but it's kind of important for making comparisons. So I just wanted to share that. And then, so this is the type of information that once you do the LCA, the EPD and the PEP summarize these important environmental impacts. And the one that's typically cited the most is the global warming impact. So this is the amount of CO2 produced. Generally, this is used as a surrogate to understand what the environmental impact is of a product. It's sometimes called global warming potential or just global warming. In this case, you can see that it's about for every functional unit, so for every 1,000 lumens, 35,000 hours, it's 239 kilograms of CO2. And then, actually, I'm going to bring up this pointer real fast. Okay. Then here you can see these are the different areas that we talked about in the LCA. So we talked about the process of raw material and manufacturing. This is the energy or CO2 created by that process. Then distribution and installation. This is the CO2 created by that process. So if I go back here, this is that transportation and installation. So that's these processes. And then the use phase, you can see that this is where most of the CO2 is being created, and this is likely due to the electricity usage because the light fixture is on, it's using energy. That energy has a certain environmental impact, and then finally the end of life. Now, the important thing to talk about here is although lighting uses electricity, and the use case here, it looks like, hey, most of the environmental impact comes from this use case. The big topic today is embodied carbon. And that's because as we start bringing online more clean energy sources, like solar, like hydro, maybe fusion in the future, those energy sources become a lot cleaner, and the environmental impact here drops significantly. And so now we start looking at the embodied carbon. What's all the energy? The embodied carbon has more of an impact on the uh, environmental impacts, on these environmental impact cases. So, the energy used to produce the product, to install the product, to transfer the product becomes a much higher percentage of the energy of the environmental impact, compared to the use phases. And so this is especially true in buildings that are implementing things like solar. They know they're going to get a lot of clean energy, so the use is less of a factor, but the embodied carbon is still a factor. And architects and designers and engineers are still setting goals um, uh, for uh, for embodied carbon. Sorry, I'm trying to turn off this laser pointer. There we go. All right. So hopefully that gives you a good idea about how these LCAs are being used and how architects and engineers are looking at this data in order to um, assess things. So how do we apply this practically into our own designs? What does this allow us to do, and how can we start small, think big, and how do we really just get going? So really, hopefully you can see how these sustainable tools they can influence the manufacturing process and the building process to help us choose healthier materials, or rethink the way that we build materials and choose kind of the processes that we do. One of the best frameworks that I know of for kind of making these choices, I discovered by listening to a presentation by Mark Ridler. He's a lighting designer out of the UK, and I highly recommend watching this YouTube video that he gave about how he makes design choices in his own lighting design practice. But this is where he introduced the waste hierarchy. It's not a new concept, but it was the first time that I really it really clicked with me about a framework for making choices around sustainability. So essentially, the best thing, the highest level of kind of choice that you can do is avoid using the material altogether. So for example, you might have a space that's daylit and you don't need to put a lighting fixture there. That's maybe the best thing that you could do. Or you could reduce things. That's the next best level. So I might have a space that's daylit, and I've written my original design. I had 2 rows of lighting fixtures, but I was able to adjust the design in such a way that I could eliminate 1 row. So I've reduced my impact by half by eliminating 1 row of fixtures in that space. You can reduce things as well by making things smaller, or making things less impactful, using less harmful chemicals. So those are some ideas about reducing. Next stage is reusing. Can I take these luminaires that were in one part of the building and reuse them because they have replaceable components? I can refresh them and use them in another part of the building. And finally, if I can't do any of those things, the next step, the next layer would be recycling. Although I can't reuse this component, but I've chosen a component that could be easily recyclable. So really the state-of-the-art thinking from a sustainability standpoint are kind of these upper 4. The things that we want to try to avoid is recovering or treating or disposing of materials, because we never ever get that material kind of back into the process. So I'll show us some different examples, and I've put in parentheses at the top how some of these types of ideas kind of fall within this in this waste hierarchy. So design for disassembly. We can design a system that's a modular design. We can avoid replacing the whole system because we're able to reuse components or replace components, so that we really extend the life of a fixture. We can reduce by making things smaller. We can create luminaires that have less waste or less weight, but also have a very similar performance. So reducing the amount of materials that go into making a fixture. We can think about using materials that might have less of an impact. compared to other materials. So looking at different innovative, maybe more natural materials in different cases. But it's important to note that when we're making these material choices, that we should also be thinking about the data that we use, because although something might seem like it's going to be more environmentally friendly because it's made out of wood or bamboo, at the end of the day, maybe it might not be because of certain processes that go into making it, whether it be high pressure heat and binders that go into making a particular lumber versus other processes that you could use for different types of materials. So it's important to be able to compare the two, because something that maybe looks like it's more sustainable might not necessarily be. It helps to be able to apply these same processes of gathering the data and making those informed design decisions, not only at the building level, but also at the product design level. So this is just an example of why it's important to kind of have that data available and make those decisions. We could build with alternative materials. Maybe we're building with recycled materials like ocean plastics or recycled acrylic or post-consumer waste, and think about how we can use those types of chemicals into the design instead of using something like a virgin material. There's more and more materials that are being made from natural sources, things like mushrooms, things like what's shown here, algae. This is a product that is removing a nuisance toxic off of waterways and algae, drying it out, turning it into a polymer, and making it part of the plastic process there, and creating a material that's carbon neutral from a from a sustainability standpoint. So there's all these new formulations for materials that are coming out to help that have an environmental impact that is less than even virgin materials. We can also rethink the way that we package materials and process materials. We can potentially reduce cardboard. So in this case, distributors for lighting, a lot of times, we might ship our products out and every product might have a box. It gets to a distributor and then they take out all the packaging, they package it up so that they can send it to the job site more easily for a contractor to install. But what if we sent products to a distributor without that cardboard boxing on it? It would be faster for the manufacturer to package, and it would be easier for a distributor to handle. So thinking about new ways to packaging things and creating programs to try to reduce the materials that go into it are the types of things that we can be doing to create more sustainable design processes. So in summary, demand transparency. This is how things are kind of help move things along and encourage manufacturers and designers to design in this way. Request documentation from your partners. Work with partners that can help you get this information, especially in a very easy way. Try to steer clear from red list materials so that you can, choose products that have the healthiest impact. Make informed decisions, and again, design for a healthier tomorrow. So that's it, everyone. That is my presentation today. I hope you enjoyed it. I hope you learned something new, and I'm happy to answer questions and happy to get any emails. So let me go back on camera here real quick.
Thank you very much, Aaron, for that excellent presentation. And, for those of you in the Raleigh area, this is very timely. You've probably heard of the news about all the issues NC State is having at Poe Hall, where they have PCB contamination, resulting in them having to close a 7-story building that houses offices, classrooms, and labs. And so NC State's been scrambling, trying to figure out how to deal with that over the last couple of months. And if you're not familiar, PCBs are widely used in electrical components. capacitors, transformers, and even lighting ballasts. So although the source of this contamination isn't known right now, it's likely electronic in nature. We do have a couple of questions in the chat that we'll start with, but also if you have questions, don't hesitate to ask Aaron. The first question in the chat was from Don Taffel, and Don pointed out that a lot of manufacturers say third-party verified, but how does the public know who has actually verified the product?
Yeah, I would say, ask the manufacturer. I know for Fine Light in particular, SES is the group that we work with to do the third party verification, and a lot of times the third party verifiers need to be certified in the process. So that's really how to know, and hopefully the manufacturers that you're working with are happy to disclose, who they're working with from a third party standpoint. But
Okay. And May Zacharin asked, on your discussion of the PEP, will the functional unit baseline be the same for all luminaires, or will it vary?
It should be. So this is one thing that we're working on in North America, to design what's called a product specification requirements for lighting in North America. And the topic of functional unit is one of the biggest topics, because right now there's no North American specification for doing an EPD or a PEP, and there are different methodologies, and one of the hardest things to do is to be able to compare two EPDs and make sure that the functional units are the same. But since these are standardized methods in Europe, the functional unit should be the same if they're using the same product specification requirement. The issue that we run into is that products that are made in Europe don't necessarily have the same energy grid or combination that they would in North America. So they're based off of kind of like the European energy grid. Although the functional units may be the same, they're hard to compare. So there is an effort right now to design a program in North America that allows for better comparability for fixtures that are made in North America, and that effort is being facilitated by a group called Smart EPD. And right now, I think they put out anybody can be part of this process for free. I think they put out a request for people to be part of the process, but that's an ongoing thing that has just started this year to develop a North American PCR so that we can align those functional units and make it the same. Sorry, that was a long answer, but that's what's going on.
Okay. A question that I have while others think of their question. So with the declare label, does that cover just the light? Does that cover the entire light fixture, a component, and does it include the packaging that the light fixture was shipped with? What exactly is that unit that the declare label covers?
So for us, it covers everything from it covers the ingredients of the light fixture itself. So what's going to be basically installed in the space. That's generally what it'll cover. And you have to have different declare labels for different types of fixtures because it's based off of the weight of the materials that are in a fixture. So for example, in Fine Light's case, you'll see that we have a declare label for aluminum fixtures and we have a declare label for steel fixtures. Because if you have a variation of more than 10% of any kind of material type that kind of takes over the weight, then those aren't really comparable. They're not comparable. So you couldn't have a label where the majority of the product was made out of aluminum and steel be kind of on the same label. So it really covers both different types of supply chain or different types of material types, kind of the core material types. And generally, it's just for the product that's kind of installed in the space. However, something like an EPD, that's going to cover the full life cycle. So that covers everything from the extraction all the way to the end of life, and that's going to look at all those different factors for the energy impacts of all of those things, including the packaging there.
All right, thank you. We've got a couple of minutes left. If others have any questions, please feel free to chime in.
Yeah, and I know it wasn't on the slide, but my email address is aaron.smith@finelight.com. So if you think of a question later, or you have a question that you want to take offline, yeah, don't hesitate to email me. I'm happy to talk about it further, especially if you're looking at doing this yourself. My biggest interest is being able to share what I've learned and be able to help others do the same thing and be successful. And I do highly recommend that you get a copy of this presentation, especially if you're a lighting designer, and check out that YouTube video from Mark Ridler. That presentation is just absolutely, it blew my mind. And I think it's just a really excellent thing that everybody should watch for sure.
Okay, and that's a good reminder that this presentation will go on our YouTube channel in a couple of weeks. There was a link posted to that earlier in the presentation, and we'll send out a reminder through IES Raleigh, so be on the lookout for that. We just got a question in, another question from Mai on with differing declare labels required, would a manufacturer provide declare labels for all their fixtures? Is that common in the industry?
Yes. So that's why I mentioned kind of being strategic. So you can cover a lot of the portfolio with a single declare label. So it depends on how manufacturers set it up, but I think more and more manufacturers are setting it up based off of product families. So you're going to see multiple product families being covered under a label. Especially in lighting, because there are similar supply chains and materials that are used across different products. But if they're very different products, like an outdoor lighting fixture and an indoor linear fixture, they're probably not going to have the same label. But you might have 100 different fixtures be under the same outdoor lighting label, let's say. It does vary from manufacturer to manufacturer, but that's generally the case.
All right. Well, we're right at 1 o'clock, so I'd like to thank Aaron again for this wonderful presentation. A lot of great information. I know I certainly learned a lot. Really appreciate your time in presenting it. And I certainly come away having learned a lot more about materials transparency and declare labeling, and hope to put it in good use. So thank you again.
Thanks a lot, Len.
Sure thing. Thank you again.
It was fun. Thanks, everybody.
All right. Everyone have a good day.